Hello everyone, I recently discovered Jupyter, which is a nice notebook system for Python. You can program in Python in your browser, which is pretty cool. And then you have support for all these kinds of interactive plots. And what I've done here is I've set up frequency modulation. So you see you have your basic waveform here, and then you can apply some perturbation to the frequency, and then you can see the effect on the timbre here on the spectrum. So this is pretty cool. You can see that when you increase the modulations, the timbre gets sharper, and you can explore what kind of or what happens if you change the index here. Like you can see they sort of move further apart. These partials generally stay the same. And you can also see the interesting effects if the indexes are really close to each other. Then you see that it fills the whole, all of the harmonics, and behaves a bit differently than if you have index bigger than 2. It also affects the phase, or the phase affects the timbre, which it does not if the index is higher. It's cool, you can study all of these things here right on the notebook interactively. But what I've done is I've added audio support for Jupyter. And here we can see that. So let's listen what we learned. So you can sort of hear that beating sound. And if I change it to 2, you can also hear the beating sound, but if the index is 3 or higher, then it's like pretty level. So we see this effect here. So no change in the spectrum, some change in the spectrum. So it's pretty cool to hear and see that. And of course, if you don't want to like play around with those kind of things, you can design your waveform right here with these separate harmonics. It's kind of hard to design anything with additive synthesis, what we are doing here, but or get anything interesting out of it. You can try. It's certainly doing something. But the great thing is that you can add all kinds of funny things here. Like you can add the modulation, even to this custom waveform. So that's pretty wild. And we can also explore the same thing here on a bigger scale. Here I've increased the range of the indices. There's basically the same thing, but now you can modify the indexes like quite widely. And what you can do with this is create this kind of bell sounds with frequency modulation, and I've done so here. So that's pretty nice. You can also make it sharper. Yeah, that's alright. Let's see. Yeah, that's not too nice. Like we can study it here if we have the carrier modulation at around 400, and the modulation is like around here. So you can see that the harmonics are really close to each other, so it sounds quite bad. So if you can separate them a bit, then it sounds better. Like let's try some of that. Yeah, that sounds more metallic and more balanced. Yeah, that's right. What I also did, or what you can also do in Jupyter, is create custom interfaces for things. So what we have here is an instrument view for a kick drum. So yeah, that's a nice punch. That's not too much. Yeah. But you can see how it affects everything. Let's try to make a more normal sounding drum here. That's alright. We also have the same here for a snare sound. Not too great, but it's completely customizable, so that's nice. So this is not a sample. It's like it's model synthesis. So everything is generated right here by the Python kernel. Also made this kind of nice bass sound. Let's make it a bit sharper, a bit funkier. Yeah, that's right. I also made this kind of grid for the notes. So here I have a beat. So these are kicks and these are snares. You can do anything you like. It's just a grid. I added a nice class, and here we have a note grid. This actually defines a certain scale, which I've added here. So this is a minor scale, and it sounds like this. And then adding the drums from here. Yeah, so it's like nothing special, but it's something I did. So you can also just like play around with this stuff and see what comes out of it. Yeah, I forgot to normalize it so it clicks. So that's, well, whatever. But it's nice that you can have an interactive melody system right here in a Python notebook. And then we have the crazy stuff, which is the ocarina. So this little instrument can be used to terrorize your neighbors. And it sounds like this. So I played some Finnish folk music earlier, and it sounds like this. Yeah, nothing special. It's the Minun kultani kaunis on. But what you can do with these kind of simple waveforms is that you can decompose them into frequency and amplitude. So I did that here, and then you can change what the sound is. Instead of playing an ocarina, you can play anything. So I don't know what this is, but you certainly can do it. Yeah, that's different. And of course, you can play around with the driving signals, the frequency and amplitude here. You can make them faster, slower, higher, anything. So what I've done here is make the song twice as fast and half as low. So it's 1 octave lower. So let's see what that sounds like. Yeah, so that's some techno with an ocarina with Finnish folk notation or melody. Yeah, whatever. But this is the kind of crazy stuff you can do when you have an audio interface to Python. See you guys next time.